Consider a function f of x that have the power series representation at x equal a, then the series of the form the sum at n equal 1, n equals 0 to infinity of c sub n times x minus a to the n is equal to c naught plus c1 times x minus a plus c2 times x minus a squared plus c3 times x minus a cubed. And is continuous. It's continuing on. Let's try to determine the coefficient of c of n in terms of f of x. At x equal a. So if I substitute a into x for this for the polynomial, then I get f of a equal to c naught, right? Now, if I go ahead and differentiate the series term by term, by doing this, I have f prime of x equal to c1 plus c2, c1 plus 2c2 x minus a plus 3c3 x minus a squared, so on and so forth. So you keep on integrating that. Now let's try to figure out what is c sub the coefficient c sub 1. Well, if I plug x equal a, then f prime of x then equal to c1. If I continue differentiate and evaluate the differential function at x equal a, then I have f double prime of a equals 2c2, f triple prime of a equal 2 times 3c3, and that is 3 factorial times c3. So it's reasonable to say that, well, if then I'm looking at taking differentiated is to the n degree, then this is the coefficient. When we plug in a, we had n factorial times c sub n. If the function f of x, so here's the theorem. If the function f of x has a power series representation at x equal a, that is, if f of x equal to the sum as n equals 0 to infinity of c sub n times x minus a to the n, where x minus a is less than r, where r is the radius of convergence, then the coefficients are given by the formula c sub n equal to the n derivative evaluated at a divided by n factorial. So if definition, if f have derivative of all order at x equal a, then the Taylor series for the function f of x at a is identified as follows. Now, the Taylor series for f at 0, or when a equal to 0, is known as the Maclaurin series for f. So let's take a look at the first example. Find the Taylor series generated by f of x equal 1 over x at a equal 2, where, if anywhere, did the series converge to 1 over x. So let's start by, we need to find the term of the series, okay? So to find the term of the series, first we need to find f of 2, f prime of 2, f double prime of 2, and see what is the parent for f to the n derivative of 2, okay? So here, f of x equal to x to the negative 1, f prime of x is equal to negative x to the negative 2, f double prime of x is equal to 2 factorial times x to the negative 3. So I can conclude that f to the n derivative of x is equal to negative 1 to the n times n factorial times x to the negative n plus 1. So then f of 2 equal 1/2 f prime of 2 equal negative 1 over 2 squared f double prime of 2 is equal to f. So f double prime, so the second term, third term, f double prime of 2 over 2 factorial is equal to 1 over 2 to the third. So f to the n derivative of 2 over n factorial is then equal to negative 1 to the n times n factorial times x to the negative n plus 1 divided by n factorial. This is equal to negative 1 to the n divided by 2 to the n plus 1. So then the Taylor series is f of 2 plus f prime of 2 times x times 2 minus a plus f double prime of a or f double prime of 2, and this should be x minus 2 minus 2 squared, so on and so forth, to f to the n derivative of 2 divided by n derivative times x minus 2 to the n is equal to 1/2 minus x minus 2 divided by 2 to the second plus x minus 2 to the third divided by 2 to the third minus so on and so forth, plus negative 1 to the n times x minus 2 to the n divided by 2 to the n plus 1, and this is continued. So now that we find the Taylor series, the next question is where does this series convert to x over convert to 1 over x? Look at the n term of this series. It represents, this is the geometric series with the first term 1/2, right? And the ratio r equal to negative x minus 2 divided by 2. So you look at this, you can see that. So this Taylor series that we got is a geometric series, because we have a geometric series with the first term a sub 1 equal 1/2, and the ratio is negative x minus a or minus 2 divided by 2. Okay, so since this is the geometric series, this convert when negative x minus 2 divided by 2 absolute value less than 1. That implies x minus 2 absolute value is less than 2. So in this case, x minus 2 is between negative 2 and 2. So then x is between 0 and 4. Okay. So the Taylor series converge when x is between 0 to 4. Let's take a look at Taylor polynomial. Let f be the function with derivative of order k for k equal 1, 2, 3 to n for some integer n contained in A as an interior point. Then for any integer from n through integer n from 0 to n, the Taylor polynomial of order n is generated by f at x equal a is this given polynomial. So let's take a look at the first example. We want to find the Taylor polynomial by the Taylor series and the Taylor polynomial generated by f of x equal ln of x at x equal 1. Okay. So first, we start with the derivative. Let's make this in 2 columns. So f of x equal ln of x. F of 1 is equal to 0. F prime of x is 1 over x. F prime of 1 equal 1. F prime double prime of x is equal to negative 1 over x squared. F double prime of x equal to negative 1. F triple prime of x is equal 2 over x to the third. F triple prime of 1 is equal to. Yeah. So then the Taylor polynomial P naught of x is equal f of 1 that equal to 0. P1 of x is equal to f of 1 plus f prime of 1 that times x minus 1 because the center at x minus 1. So we get x minus 1. P2 of x is equal f of 1 plus f prime of 1 of x times x minus 1 plus f double prime of x minus 1 square, plus f double prime of 1 divided by 2 factorial times x minus 1 square. This is x minus 1 plus 1 over 2 x minus 1 square. And you can continue for p sub 3. Now, what I want you to see is that we want to compare the graph of f of x with the polynomial approximation. So if you are going to graph this using decimal or any graphing device, you can see that P naught of x is just equal to 0. P1 of x is the line that blue. You get a straight line, and then you look at P2 of x. That is kind of a parabola. Now P3 of x, you get this red curve. It is the approximation of the curve f of x equal ln of x at x equal to 1. So the mode of the mode of the polynomial that you use, the curve will become it will become closely related to f of x equal ln of x. You will get an approximate curve of it. So let's say what happens if you want to find the Taylor series for f of x equal cosine of x at x equal to 0. Again, we go ahead and find the derivative and evaluate at 0. So first of all, f of 0. So f of x equal cosine of x. F of 0 equal 1. F prime of x equal negative sine of x. F double prime of x equal negative cosine of x. Okay, so if you keep on going, if you take derivative 2n of x is equal to negative 1 to the n cosine of x, right? And you can see that this is keep on going. And if you do one more, it alternated in sign. So 2n plus 1 x, that equal to negative 1 to the n plus 1 sine of x. Now you can evaluate this at x equal to 0. F prime of 0 equal to 0. F double prime of 0 here equal 1. So as you can see that the sign is alternating as well. The value alternating between 0 and 1. So then I can write the Taylor series. That is f of 0 plus f prime of 0 times x plus f double prime of 0 divided by 2 factorial times x squared plus f triple prime of 0 divided by 3 factorial times x to the third, so on and so forth. So this series become 1 plus 0 times x minus x squared over 2 factorial plus 0 times x to the third plus x to the fourth divided by 4 factorial plus so on and so forth plus negative 1 to the n of x to the 2n divided by 2n factorial. Continue adding, right? So as you can see that this is the sum at n equal to, as k equal to 0 to infinity of negative 1 to the k times 2 times x to the 2k divided by 2k factorial. Okay. So what I want to do, I want to try to see if we can get the graph of each of this polynomial. Okay. So let's see what if you so when you try sketching this, if you So if you go ahead and label out what is your P0, P1, P2, P3, P4, P5, you can plot all 5 of this curve, and you can plot the curve for cosine of x at the same time on the same axis, on the same xy coordinate plane. You should see that as the polynomial increase, you will have the approximate curve of f of x